Okay, so this is day 2 of hyperbolas, which is writing equations of hyperbolas. The first part is a warm-up of graphing 2 hyperbolas. If you are having issues with graphing, you can watch this. If not, you can fast forward to the writing part. All right, so first off, I want to know the orientation. Remember, for hyperbolas, you look at the numerators. Since it's x then y, this is horizontal. Now I need to find the center. That's hk, which is -2, +1. I can graph that, -2, +1. And then I need to find my vertices. My vertices are a units from my center, where a squared is the first term no matter what, the first denominator. So I have a squared is 16. So a is positive and -4. Now I'm going horizontally. So I'm going to go right 4. And then I like to make my vertices stand out. 1, 2, 3, 4, left 4. So my vertices are at 2, 1, and -6, 1. Okay, now I need to get b so I can make my framework. So I'm going to do b squared is 25. b is plus or minus 5. So I'm going to go from my center, I'm going to go up 5, make a point, and I'm going to go down 5, make a point. Now I'm going to use my vertices and these 2 green points here to create a rectangle. Okay, so I'm going to come up from that point and then over to this point and then over to the yellow point or orange, whatever color that is considered. Gold maybe. Oops, I went too far. Delete, delete. Okay, and then this way and then over here. All right, so there is my little rectangle there. The reason I draw this is so that we can have an accurate slope on our asymptotes. This will give us the correct slope of our asymptotes, and that's why we need that rectangle there. And then out the corner here. Okay. Now you can graph your hyperbola. You can go back to your vertices. That's why I make them bold, so I don't have to say, like, which ones are my vertices. I don't know why this side doesn't look so great. There we go. Okay. It doesn't look perfect, but whatever. Just gonna move it over a little bit. Never mind. Stop it. Just leave it. It's fine. Okay, so there is my hyperbola. Okay. All right, so let's try another one just to make sure we're set here. So first off, the orientation. Remember, I look at the numerators. This goes y, then x. So this is a vertical hyperbola. HK is 5, -1. Remember, H is with x, K is with y. Oh, I forgot about my foci in the last one. So my foci I get by doing c squared equals a squared plus b squared. If you forget which one it is, look here and don't do that. Okay? So I have c squared is equal to 16 plus 25. C squared is equal to 41. Square root plus or minus. Square root plus or minus. Root 41 is not simplifiable. I do have to approximate it. It's less than root 49, which is 7, so this is 6 point something. Okay, so I look to see which direction I'm going. Horizontal. So from my center, I'm going to go right 6 and left 6. 4, 5, 6, and then a little bit more. From my center, I'm going to go left 6, and then a little bit more. Not this. And those are my foci right there. So now I'm going to say the location of them. If you look, they're floating. Oops. They're floating in between 2 x values here and here and here and here. So I can't just say like, oh, 2, 7. I can't do that. So I'm going to use my center for help, right? I went horizontally from it. So I'm going to say from the -2, I went right and left to root 41. But then I stayed at 1. Okay, let's move on to this one. It's vertical because it's y then x. HK is 5, -1. So I'm going to graph that. 5, -1. All right, now I need my vertices. My vertices are a units from my center, where this is a squared no matter what. So a squared is 36. A is plus or minus 6. I'm going vertically, so my vertices are going to be up 6 and down 6. 3, 6 right there. And then 3, 6 right there. So there's my vertices. That's at 5, 5, and 5, negative 7. 5, 5, and 5, negative 7. All right, so now I need B to make my framework. So I'm going to say B squared is 4. B is plus or minus 2. So I'm going to go right and left 2 from my vertex, or sorry, from my center. And then I'm going to create a rectangle from this. Create your asymptotes that go through the corners. So very steep sloped asymptotes here. Okay. And now I can go back to my vertices and make my hyperbola. So this is vertical hyperbola, but I can tell because of where my vertices are giant. Also, notice that I'm getting closer and closer to the asymptotes. I'm not bouncing off of them. And there's my hyperbola. Last thing I need are my foci. My foci are c units from my center, where c squared is equal to a squared plus b squared. So that's 40 this time, square root plus or minus, square root plus or minus. This time it is simplifiable. 4 goes in there 10 times, so that's plus or minus 2 root 10. I need to approximate this. I'm going to use the 42, the 40 to do that. 40 is more than 36 and less than 49, so it's 6 point something. Okay, so now I'm ready to graph my foci. I'm going to go back to my center since it's vertical. I'm going to go up and down 6 and a little bit more. There's my center. I'm going to go up 1, 2, oops, I'm making little points there. 1, 2, 3, 4, 5, 6, and then a little bit more, and then down 6 and a little bit more. So notice, and that's from my center. I noticed like I knew that this one was right above my vertex, so I knew this one's right above my vertex. Okay, so floating once again, so I'm going to use my center for help. I moved vertically, so I'm going to change the y value. So the 5 is going to stay the same, but from -1, I went up and down 2 root 10. And that's it. Okay, so let's move on to writing equations of a hyperbola. If you look at these 5 examples, they're all pretty similar, and you'll see why as we start to do them. Write an equation of a hyperbola with foci at 2, -2, 2, -12, and vertices at 2, -3, 2, -11. So first off, I need a sketch. I can't draw a skeleton yet because vertical and horizontal hyperbolas have different skeletons. One has x first, then y, and the other one has y, then x. So I need to know what it is before I write down a skeleton. Okay, my foci are at 2, -2. So write 2 down 2, 2, -2, and 2, -12. So down here. And I'm going to put an F there so I remember that it's the foci. Okay. The other information that they gave me is my vertices are at 2, -3, which is right here-ish, and 2, -11. So if you look at these points, they're all vertical of each other, so I know this is a vertical hyperbola, but you could also think of it as this has to wrap around that, and this has to wrap around that. So it's a vertical hyperbola. So I'm going to write down the word vertical so my brain gets moving. And now I'm going to write down my skeleton. So for vertical, it goes y then x. So this is y minus k squared over a squared minus x minus h squared over b squared equals 1. You can write k and h right here if you want and then erase them as you go. Doesn't matter. Okay, so let's get our center first. Our center is directly in between our 2 vertices and directly in between our 2 foci. So I know it's definitely over 2. But then I know that it's in the middle of -3 and -11, or in the middle of -2 and -12. So in other words, the average. So I'm going to do negative 3 plus negative 11 and then divide it by 2. That's negative 14 divided by 2, which is negative 7. So if you think about it, you could have also used the negative 2 plus negative 12 divided by 2 because that's still negative 14, right? So my center is 2, negative 7. So I'm going to take h and get rid of it and put a 2 there and get k, get rid of it, oops, and put k and get rid of it and put a negative 7. So it becomes plus 7. Okay, now I'm ready to get A and B. So A is the distance from the center to a vertex. So center to a vertex would be this right here. That's A. So from negative 7 to negative 3 is a distance of 4. So A squared is 16. Erase this, 16. Now I need B squared. In B squared, I can never give you B, because what am I supposed to say? They don't have a name. They're not called co-vertices. So I'm always going to have to give you foci, right? So you're going to have C instead. The distance between the center and the focus is C. Between negative 7 and negative 2, that's a distance of 5. So now I'm going to use C squared equals A squared plus B squared in order to solve for B. So I know C squared is 25 because C is 5. A squared 16, and then plus B squared, and then just solve for B squared. Subtract 16 from both sides, and I get 9 is equal to B squared. Remember, don't square root because you're looking for B squared, not B. So this is 9 right here, and that is all. That's it. Okay? All right, let's move on to the next one here. Same exact idea. Write an equation of hyperbola with vertices. So I'm going to draw my x and my axis here. So this time, I'm just going to do it all purple. It's not going to hurt anyone. All right, vertices are at negative 1, 3. Left 1, up 3. So negative 1, 3. I'm going to put a V right there so for vertice. And then 3, 3. Over 3, up 3. 3, 3. Put a V there for vertices so I know. Okay, next we have our foci. Our foci are at negative 8, 3. So negative 8, 3. So which is right there-ish. This is my focus, negative 8, 3, and 10, 3. So even farther over, it won't let me even draw a point that far. So I'm going to have to move this. There we go. So 10, 3. Let's see, it's right there. Other focus, 10, 3. Okay, so once again, I can see that all these points are horizontal, so I know that this is horizontal. Right? But another way of thinking of it is that your vertices have to wrap around your foci, right? So I know it's horizontal. Okay, so since it's horizontal, I'm going to write x minus h squared over a squared minus y minus k squared over b squared is equal to 1. All right, we're going to get our center first. You always have to start by getting your center first. So my center is located directly in between these two. This will be my center. Now, I don't know how far over it is to the right, but I know how far up it is. It's 3. But I can figure out how far it is over to the right. It's directly in between negative 1 and 3. Negative 1 plus 3 divided by 2. 2 divided by 2, 1. So it's at 1, 3. I could have used 10 and negative 8 also. Negative 8 plus 10 is 2. 2 divided by 2 is 1. So my center is 1, 3. I'm going to erase h and k, which that's why I like to not write them so I don't have to erase them. 1, 3. All right, now I need a squared. A is the distance from that center you just got to a vertex. So center to a vertex, this is A. From 1 to 3 is 2. So a squared is 4. Now I need b squared, and I'm going to use c to help me get that. So c is the distance from the center to a focus. So c is from 1 to 10, which is 9. So now I'm going to do c squared is equal to a squared plus b squared to get b squared. 81 equals 4 plus b squared. Subtract 4. 77 is b squared. So I can put 77 in for b squared. And there is my answer. Let's box it. All right, next one, write an equation of a hyperbola with vertices at. So once again, start with your sketch. I have 0, 3, and 0, negative 3. These are vertices, V, V. Foci are at 0, 5, and 0, negative 5. So you can see this is vertical. All right, so we're going to do y minus k squared over a squared minus x minus h squared over b squared is equal to 1. All right, so I need my center first. My center is directly in between these two green vertices, or the purple foci. It's definitely over 0. And then it clearly it's at 0, 0, but in case I made a mistake, negative 3 plus negative 3 is 0, divided by 2 is 0. So 0, 0 is correct. So what I'm going to do is, instead of putting 0 here and 0 here and having y minus 0 squared and x minus 0 squared, I'm going to put x squared and y squared, or sorry, y squared and x squared. So y squared and then x squared. All right, now I'm going to get A. A is the distance from the center to a vertex, so A is 3. So this is 9. And now I'm going to get B by using C. C is 5. That's this distance. And then C squared equals A squared plus B squared. So 25 is equal to 9 plus B squared. Subtract 9. And we have 16 is equal to B squared. Okay. Next one. Write an equation of a hyperbola with foci at negative 4, negative 2, and a transverse axis with a length of 8. So write an equation of a hyperbola with foci at negative 4, negative 2. Well, that's not pretty, but it's okay. All right, so negative 4, negative 2, left 4, down 2. So that's right there. And this is a focus, so F is negative 4, negative 2. And then I have 8, negative 2, so write 8 down 2, all the way over here. 8, 2, and we'll say this is a focus also. All right, well, I know once again that this is horizontal, not once again, but I know this is horizontal because those points are horizontal from each other, horizontal. So I can do x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Did I put a minus? Yes, I did. I was making sure I made this one as a minus. It is. Okay, I need hk, which is my center. So my center is directly in between these two. So my center is going to be at something, comma, oops, I see a mistake I wrote down. This is 8, negative 2. So I know it's something, comma, negative 2. And to get that something, it's directly in between negative 4 and 8. So negative 4 plus 8 divided by 2 is 2. So it's at 2, negative 2. So h is 2, k is negative 2. Now I need a squared. A is the distance between my center and my vertices. Wasn't given it. I need b squared. It's the distance between my center and then those other 2 points. I wasn't given it. So I was given c, but I need either a squared or b squared to do this. So I say, wait, what was the other information I was given? I was given that the transverse axis has a length of 8. So that means that the distance from the vertex, which is, let's say it's right here and right here, this is 8. That means this right here, a is 4. Okay, so now I know a squared is 4, or sorry, a is 4, so a squared is 16. Now I can get b squared using c and a. All right, so the distance between my center and my focus from 2 to 8 is 6. So now I'm going to do c squared equals a squared plus b squared. That's 36 is equal to 16 plus b squared. Subtract 16. And we have b squared is 20. So I can erase this b squared, and I can put a 20 here. All right, the very last problem is actually a look into the next section. So it says, given the parabola y equals 2x squared minus 12x plus 3, how can we rewrite this easily to find the vertex? So this is standard form. And if we write it in vertex form, we'll easily be able to tell what the vertex is. So I want to remind you of how to do this, just so that when we do it tomorrow, it's not that big of a deal. Okay, so to get into vertex form, You have to complete the square. You learned this in your quadratics chapter in Algebra 2 with trig. Okay? So here are the steps of completing the square. So first off, you just want the x squared and the x to be on one side of the equation. So I'm going to start by subtracting 3 from both sides. So I have y minus 3 is equal to 2x squared minus 12x. Now, you can only complete the square if x squared has a lead coefficient of 1. It does not have a lead coefficient of 1 right now. It has a lead coefficient of 2. So I need to factor the 2 out of both of these terms right here. So it's not the GCF that I'm factoring out. I'm not factoring out a 2x. I'm just factoring out the lead coefficient. So I have 2 times, and then that's x squared minus 6x. Okay, now instead of putting a parentheses on the end, what you're going to do is you're going to leave a space right here to complete this square. What you're doing is you're making this quadratic. Let me zoom out right here. You're making this quadratic a perfect square trinomial, meaning I want it to be factorable to like x plus 4 times x plus 4, x minus 2 times x minus 2. I want it to do that. So in order to get that to happen, what you're going to do is you're going to take half of b, which is negative 3, and square it. Half of negative 6 is negative 3. Negative 3 squared is 9. Okay, so now I just made that a perfect square trinomial. But by adding 9 to that side, I just changed the value of the right side of the equation. And I can't just add 9 over here to balance it because it's not 9. It's 2 times 9, which is 18. So I have to add 18 to this side. So now I have y plus 15 is equal to 2 times, and now this will always be factorable to a binomial squared. So two numbers that multiply to give you 9 and add to give you negative 6 are negative 3 and negative 3. They should always be the same, so it's x minus 3 and x minus 3. All right, the last thing you have to do to complete the square to get x by itself is to get y by itself. So subtract 15 from both sides, and I have y equals 2 times x plus 3 quantity squared minus 15. So now you can see what your vertex is using HK here, and you get your vertex is negative 3, negative 15.